The following is a tutorial on Bronsted Lowry acids and bases. So the first thing we're going to do is we're going to look at a chemical reaction and determine which one is the acid, the base, the conjugate acid, and the conjugate base. So you need to know that an acid is a proton, write that down, donor. Okay, and when I say proton, I mean hydrogen. And a base is a proton acceptor. Okay, for the definitions for conjugate acid and conjugate bases, you'll need to refer to the notes. A little bit too much to write on here. Okay, so in our first example, I've got nitric acid reacting with water to form hydronium and nitrate ion. So what I'm going to do is I'm just going to start by looking at the first part of the equation. So I have HNO3. So I'm going to look at the other side of the reaction and find something that looks like this. Okay, so that would be this one right here. So the question is, did it lose a hydrogen or did it gain a hydrogen? In this scenario, we've got a hydrogen on this side, but it does not have a hydrogen with it on this side. So what's happening here is nitric acid is donating its hydrogen to water. So that makes this the acid and this one the base by default. However, we could have looked at water first. Okay, we'd look at the other side of the reaction to see something that looks like that. It would be this one right here. And in this scenario, I went from 2 hydrogen to 3 hydrogen. So it gained a hydrogen. That means it's the proton acceptor. It accepted a hydrogen. So next thing we need to look at is the conjugates. So every base has a conjugate acid and every acid has a conjugate base. A conjugate base is the remainder of the acid after it loses its proton. So if you look on this side, here is the HNO3 without the hydrogen. That makes it the conjugate acid. In this scenario, we got a conjugate acid. Excuse me, that was supposed to say conjugate base, I apologize. Conjugate base is the remainder of the acid without the hydrogen. Conjugate acid is going to be the base once it gains a hydrogen. Okay, so with the one additional hydrogen, conjugate acid. All right, next problem. We've got ammonium reacting with water to form ammonia and hydronium. So in this scenario, I've got NH4, so I look on the other side to find something that looks similar to that. That would be this one right here. And again, from here to here, I've lost a hydrogen. I'm going from 4 to 3. So this must be giving up a hydrogen to water. Okay, so in both of these scenarios, water is acting as the base. Okay, and again, we could have looked here and saw that this one is gaining a hydrogen because on this side it has 2 and now it has 3. So it is a proton acceptor. So H3O plus would be our conjugate acid. Okay, which remember conjugate acid is the base once it gains a hydrogen. Okay, and the next one, NH3, that would be the conjugate base. It's the remainder of the acid after it loses its proton. Okay, so one less hydrogen. Next example, I've got phosphate ion reacting with sulfuric acid. So on this side of the reaction, I've got PO4 3-. On this side, it's HPO4 2-. So it gained a hydrogen, so this is my base. And this one goes from 2 hydrogen to 1 hydrogen. So that is our proton donor. It's donating a hydrogen to the phosphate ion. So that would be my acid. Okay, the conjugate base is going to be this acid with 1 less hydrogen. So that's this one right here. And then we've got our conjugate acid, which is going to be this base with 1 more hydrogen. Okay, so let's now do it a little bit differently. So now I'm giving you a base and I'm asking you to write the conjugate acid. So the conjugate acid is the base with 1 more hydrogen, now that it's accepted the proton. So 2 things we need to think about here. First of all, we got to add hydrogen, and then we need to look at what the charge is going to be. So the charge on hydrogen is +1. Okay, 1+. So this one, overall I have a -1 charge. Okay, write that right here. So I have a -1 charge on this molecule, and now I'm going to add a +1 charge because I'm going to add hydrogen to it. So -1 plus 1 equals 0. So my overall charge is going to be 0. HCN. Okay, and the next one, let's do NH3. So once it gains a hydrogen, okay, now it's going to be NH4. Okay, in this case, I'm starting with an overall charge of 0. There's nothing up here, so the overall charge is 0. And I'm adding a hydrogen to it. So now my overall charge is going to be 1. So I'm going to put a positive sign right there. It's +1. Okay, and then the next one, got sulfate ion. So if it gains a hydrogen, it's going to be HSO4. Okay, in this case, I have an overall charge of -2 to start. I'm going to add 1. So now you're going to have a -1 charge instead of -2. All right, and then for this one, we're writing the conjugate base. So the conjugate base is the remainder of the acid after it loses a proton. So I'm going to draw it with 1 less hydrogen, so now it's going to be H2PO4. Okay, and we're going from an overall charge of 0, and we're removing a hydrogen, so we're removing a +1 charge, so now the overall charge is -1. Okay, in the next one, I've got H2O, so now it's going to become HO, but the convention is to write it as OH, and I'm going from a charge of 0 -1, so now the overall charge is -1. Okay, so we took away a hydrogen, which has a +1 charge, so now overall it's -1. In this example, I've got HSO4, so if it loses hydrogen, it's going to be just SO4. My overall charge right now is -1. I'm going to take away another charge, so now overall it's -2. Okay, so it's -1. I'm taking away hydrogen, so you can think about it as change the process, change the sign. -1 plus -1 is -2. Okay, and then the last one, we're going to complete a reaction. So I have written in the product side. So I wrote in our conjugate acid and our conjugate base. So the conjugate acid is the base once it's accepted a proton. So we're working backwards now. So what I'm going to do to figure out the base is I'm going to write this same thing, but with 1 less hydrogen. Okay, it's going to become NH3. So at a +1 charge, I took 1 hydrogen away, so now the overall charge is 0. And then the conjugate base is the remainder of the acid once it loses hydrogen. So I just draw it on this side with hydrogen. Okay, so you can go ahead and check your work. Okay, going from here to here, I am gaining a hydrogen, which means this is my base. And then from here to here, I lost a hydrogen, so that's my acid and its conjugate base.